We're in the University of Florida's virtual scan lab. Throughout the experience, the arrow guides you to objects and the finger shows the interaction. To press an object, point your finger at it and push forward. Now press the button to begin the lab. Great, let's get started. X-ray tomography allows for detailed physical inspection of PCBs using X-rays. Now try to grab this chip. To grab, reach out and grab the object with your hand, then release to drop. Good job. X-rays can penetrate objects that are opaque to visible light, allowing us to analyze their internal materials. This is an X-ray tomography machine. Let's jump in and see how it works. Grab the knob and open the door. There are 3 primary components inside the X-ray tomography machine. Reach out and press one to learn more about it. The test bed holds and rotates the chip during the CT scan. Capturing images from multiple angles lets us reconstruct a 3D projection of the chip. The chip should be placed in a vertical orientation. This optimizes X-ray travel and reduces the number of images needed per scan. The detector uses a scintillator, similar to a camera sensor, but it captures X-rays instead of visible light. Photodiodes convert the incoming light into electrical signals for an image. The X-ray source directs X-rays toward the chip we're inspecting. Different materials absorb different amounts of X-ray, which allows us to distinguish them in the final image. Let's try out the equipment. Grab the chip and release to place on the test bed. Good job. Proper alignment reduces geometric unsharpness, which helps minimize blurring at the edges of the object. Adjusting the distance between the X-ray source and the object by moving the sample stage is a key part of X-ray imaging. This adjustment directly affects the magnification, resolution, and field of view in the resulting X-ray images. Bringing the object closer to the X-ray source increases magnification, which enhances detail but may also introduce distortion. Grab the stage and move it around. Good job. Balancing voltage and current is essential for producing high-quality X-ray images. Higher kilovolt increases X-ray penetration, but more isn't always better. You'll need to balance it with MA to get the desired result. Increasing the current reduces image noise, but too much can introduce visual artifacts. Take a look at this image. Try increasing the voltage kilovolts and see how it enhances. Good job. Notice how the contrast and brightness of the image change. See the noise in the image? Let's increase the current and observe what happens. Good job. See how increasing the current helped reduce grainy artifacts. Congratulations, you're now familiar with the voltage and current controls. Now that you know how the machine works, let's have you try it out on your own. Place the chip on the test bed. Good job. Try to match the provided image using the controls. If you're getting stuck, press the green button for help. Good job. Let's test your knowledge on X-ray tomography. Select the correct answer by clicking on one of the options below, A, B, C, or D. Once you've made the selection, you'll receive feedback and move on to the next question. Let's get started. Good job. Let's learn more about it. Grainy X-ray images often occur due to quantum noise, which happens when too few X-ray photons reach the detector. To reduce this noise and produce a smoother, clearer image, increasing the tube current milliamps and voltage kilovolts can help. Doing so increases the number of photons generated per unit time, which improves the signal-to-noise ratio, SNR, and enhances overall image quality. Good job. Let's learn more about it. Voltage kilovolts controls the energy of the X-ray photons. Higher energy photons can penetrate dense materials more effectively, making them essential for imaging objects like bone, metal, or large samples. If the energy is too low, the X-rays may be absorbed by the material before they reach the detector, resulting in a poor image. Good job. Let's learn more about it. In cone beam and fan beam CT, geometric magnification happens when the object is positioned closer to the X-ray source and farther from the detector. This increases the size of the projected image, but can also introduce geometric distortion, blurring, or cone beam artifacts because of the angular divergence of the X-ray beam. Good job. Let's learn more about it. In CT imaging, creating a 3D reconstruction requires capturing multiple 2D projections from different angles. The rotation stage, also known as the gantry, physically rotates the sample during the scan to collect these varied views. Good job. Let's learn more about it. X-ray detectors typically use scintillators or direct conversion materials, such as amorphous selenium or cadmium telluride, to convert incoming X-rays into visible light or electrical signals. These signals are then digitized to enable image reconstruction. Congratulations! You've completed all the questions.